Okay, thank you very much. Good to see you all here this morning, bright-eyed, after whiskey tasting last night, which is great. And I'm here to try and convince you about the importance of this parameter, the lamp exposure limit. First introduced by Columbia University, so I'm not going to take any credit for it at all. But I think it's a really powerful tool, and I think it's a tool that actually each of the manufacturers, the lamp manufacturers, should provide, so that when you're doing risk assessments, you're doing installations, or even inspection bodies, they can accurately compare those installations and do those risk assessments to the ICFUST and ACGIH guideline exposure limits. But in order to convince you of the importance of this, I need to start with what the difference is between exposure and effective exposure. It's a critical, that one single word is critical in there. And then I'll go on to explain why it matters and what the lamp exposure limit is. The ICFUST and ACGIH limits are effective exposure limits. Not exposure, but effective exposure. And although the two equations look very similar, the effective exposure builds in an action spectrum. And that action spectrum takes into account the biological effect of the different wavelengths of light. Can anybody tell me for Far-UVC what the ICFUST exposure limit is? Just shout out.
23.
23. What about the ACGIH exposure limit?
161.
161. Okay, wrong. ACGIH and ICFUST actually they have both the same exposure limit. Okay, and that exposure is an effective exposure limit of 3 millijoules per centimetre squared. All right, they actually agree with each other. Where they differ is in their action spectra. Okay, and the action spectra changed back in, it was 21, 22, around then. And so it can be quite surprising, as we've talked about, those different numbers, but those different numbers only apply to a single wavelength. Okay, and they're calculated by taking the effective exposure limit of 3 millijoules per centimetre squared and dividing it by the point on the action spectrum that you can see highlighted in the slide. So they only apply to a single wavelength. They're only appropriate when there's just a single wavelength. And krypton chloride lamps are not single wavelength sources. We all talk about filtered and unfiltered lamps, but as you can see here, these are 14 commercial Far-UVC sources that have been very kindly lent to us by various manufacturers and measured in our laboratory, and there's a lot of variation in there. The y-axis is on a log scale, so you can see there's a couple of orders of magnitude variation. It's not just a filtered and unfiltered source. There's a spectrum in there. And so we can't just use the simple exposure limits at a single wavelength, and hopefully I'm going to prove that to you. Let's take just two of those lamps, lamps 3 and 13. They have different spectra, but as you can see from the top line on the table, they have very similar irradiances. So if you were to take the ACGIH skin exposure limit, for example, and we'll say at 222 nanometers, it's 478 millijoules per centimetre squared, and you calculate then the exposure time before you would reach that limit. So if you were to do that with lamp 3 and lamp 13, they come out roughly the same, 48 to 50 minutes. But actually, if you look at the effective exposure limit, so you take into account all the other wavelengths, and you find the effective irradiance of the lamps is very different. You see that at the bottom half of the table. They're very different to each other. And if you take then the effective exposure limit and work out the exposure time to reach that limit, then you see you have two very different exposure times. It's still roughly about that 46 for lamp 3, which is close to the 50 as it was before. But for the lamp 13, which happens to be an unfiltered lamp for this example, you can see that there's a much lower reduction time. So, in theory, if you'd gone off of 478 millijoules per centimetre squared, you could have overexposed somebody by more than 4 times what the guideline exposure limits are. So that's how critical it is to take into account those extra wavelengths. But if you're going to do that, you need to know what the spectrum of the light source is. And in the field, it's very difficult near impossible in order to accurately measure that spectrum. And so that's where the lamp exposure limit comes in. If we take the equation between exposure and effective exposure, we can combine them in a way to calculate the lamp exposure limit. As I say, first introduced by the Columbia group, very powerful tool. And the great thing about the lamp exposure limit is that once you have it for a particular lamp and a particular spectrum, it doesn't change. So it's the same, it doesn't matter with distance. It might change with angle, but only because the spectrum changes with angle. But primarily, that number doesn't change. So it's a single value that is easy to calculate and can be provided by the manufacturers in a very straightforward fashion. And it would also apply to other Far-UVC sources. It also applies to LEDs or other spectra as well. And that means that when you go out into the field and you've only got your broadband radiometer, a calibrated broadband radiometer, and I can't go into how important it is to make sure it's appropriately calibrated, but there was a talk last year from Mike Clark on calibration, so you can look at that, but it has to be calibrated. And then you can measure the irradiance with your calibrated radiometer. So let's now take the example from previous, but substitute in the lamp exposure limit for these two lamps. And on lamp 3, you can see it's much higher than the lamp exposure limit on lamp 13. And if we then go on and work out the exposure time from that, you can see that the exposure times as calculated and measured with the broadband radiometer are now more appropriate and closer to the times as measured with a spectral measurement system. And it also has the unintended consequence of actually demonstrating how good filtering is in a system. Because the better the filtering, the closer the lamp exposure limit will be to the single wavelength exposure limit. So you can see that here, where the lamp 3 is almost the same in its exposure limit as the single wavelength at 2 nanometers. So I hope I've convinced you that the lamp exposure limit is important, that it's a very useful parameter, and I just want to say thank you to everybody for listening.